Welcome. Thank you for coming to see us here. I'm Justin Murray from VMware's Technical Marketing, and my co-speaker, I'm honored to have Dwight Lahiri here from Cloudera.
Hi guys, I'm
How
Dwight
come I
Lahiri.
didn't get the applause?
I'm a solution architect at Cloudera, and I'm glad to be here speaking with Justin.
Thank you, Dwight. We'll conduct this in somewhat conversational style, but I'll get things warmed up here for the first few minutes, just to get things going. So the disclaimer slide is actually quite important in this section, in this particular talk, because we are definitely going to talk about future technologies here. I'm going to introduce you to some innovations that are going on at the engineering level between the partner engineering team and ourselves at Cloudera. So Cloudera and VMware are working closely together, and I'll give you some insights into that. And that's not yet a product from either company. What you're going to see is a technical preview, so all the caveats in the disclaimer apply, particularly to this talk. So our agenda then is, first of all, talk about why virtualize Hadoop. How many people here are very familiar with Hadoop? Have already done Hadoop in serious projects? Several people have, thank you. And how many people have tried virtualizing Hadoop on vSphere? About 4 or 5 people, that's very good. And how many people are planning to or looking into virtualizing Hadoop in the future? Thank you. Thank you, most of the people here. So that's a good sign. If you think about it, most of the public clouds in the world that people are talking about as the next platform are already virtualized in some shape or form. They're already running Hadoop on their platforms, so there's no reason you shouldn't run them in-house on your in-house virtualization platform. So myths about virtualizing Hadoop is actually an important section. This talks about shared storage versus direct attached storage, and there's a big debate going on as to which is the more applicable. So we'll talk about that a little bit. I'll give a very brief introduction to the Hadoop architecture. We'll give an overview from Dwight of the Cloudera portfolio. And we've been working with Cloudera now for all of the years that I've been involved with big data at VMware, which is 4 years. So we've been testing Cloudera's software out on vSphere for well over 4 years now, and there is a brand new performance paper on Cloudera being published this week at this show that you'll see. It's called the vSphere Performance Best Practices for vSphere 6 and Cloudera. So a lot of reference architecture work, a lot of performance testing work has already been done, and we're going to talk about those innovations that I referred to earlier. Those have to do with Cloudera Director. Cloudera Director is the tool for deploying Cloudera onto public cloud and now onto vSphere as well, the same tool to deploy Cloudera onto public and private cloud. And we'll be talking about that as we go forward. So these are the types of situations that I meet quite a lot, which is IT wants to provide CDH clusters as a service for their end users, on demand. Press a few buttons, and I've got a cluster. And they want the business users to be able to use this, the data scientists, the data engineers, not necessarily to be involved every day from an IT perspective. And I'm going to show you that, or at least a prospective user interface, a potential user interface to do that through Director. Development, testing, production, pre-production, staging, system testing, all require their own cluster generally. They want to be testing the new version in development, the second from the newest version in pre-production, and the version that's been tried and trusted in production. So 5.8 in development, 5.7 in testing, and maybe 5.5 is in production right now. How do you run all those 3 versions together? Well, you put them in virtual machines, you put them on top of vSphere, they're isolated from each other by virtual resource pools, and you can do that together. Or how would you run one distribution of Hadoop on one set and another distribution of Hadoop on the same set? You can't do it on bare metal. So many of our customers have actually got mixed versions in these different areas. Many have different releases of Hadoop for different teams and different services like Impala or Spark or HBase for different purposes, different business units. They want to run these Hadoop clusters. A Hadoop cluster is a collection of nodes or a collection of machines that I'm going to show you in a second. And with these different types of cluster, you need virtualization to help you. A lot of the work inside Cloudera itself is done on virtual machines for development purposes. and we'll talk about that. So virtualizing Hadoop or Cloudera distribution, including Hadoop, which is CDH, avoids the need to dedicate hardware to just one purpose, one cluster. You may do that for production, but pre-production, user acceptance testing, QA, development, all of those can share one cluster of hardware with different versions operating on there if they're virtualized. So that's really the type of scenario that I'm in every day with our customers. I'm going to a meeting about this with our customers in a few minutes after our talk here, and that's very typical. So there are many things that people believe that are actually not true out there about Hadoop and virtualization. So virtualization will add significant performance overhead. Not true. I'm going to show you how VMware virtualizes Hadoop, and not just Hadoop, but the very latest version of it called Spark, and the very latest type of applications on top of Spark called machine learning applications, where you're training a model to spot a fraudulent credit card transaction, for example. These applications run fine on vSphere. They run actually on par with native if you do it the right way. And the right way is to fit your virtual machines into the memory of the server so that you're obeying the NUMA boundaries. That's all there is to it. We'll talk more about that. Hadoop cannot work with shared storage. There's a particular type of shared storage that we see regularly. In fact, Dwight and I are working on a customer situation now that uses the Isilon form of shared storage from EMC. That's a form of storage that understands the Hadoop distributed file system HDFS. Perfectly acceptable for Hadoop environments. Is my SAN perfectly acceptable for Hadoop? Well, I would say tread with caution with your SAN and your blades. Build a Hadoop cluster that is 6 servers or thereabouts, 12 to 20 nodes, 12 to 20 virtual machines, and you're going to be fine. But if you run that Hadoop cluster up to very high levels of performance and increase it to 20 servers or 30 servers, then you'll probably saturate your SAN. So we're going to show you architectures that are using direct attached storage, which is the most common way to do Hadoop, or Isilon storage, the most common shared storage way to do Hadoop. If you go outside those boundaries, you're a little bit on unknown territory as far as the reference architecture is concerned. So tread with caution. Keep your clusters very small if you do them in that way. So shared storage is a valid choice, particularly Isilon, and you're going to see that in our reference architecture. If you're doing traditional blades and SAN, stay with smaller clusters and you're quite safe. Does virtualization require the use of shared storage? Absolutely not. If Cloudera recommends to you that you buy direct attached storage for your Hadoop cluster, that's perfectly acceptable to do virtualization on there. So we have at least one customer that I know of that has many hundreds of servers with all direct attached storage, all operating Hadoop on a virtual platform on vSphere in production. And those are written up in our list of references I'm going to give you at the end. So while shared storage is useful for HA, and HA is actually taken care of inside Hadoop as well, virtualizing Hadoop on direct attached storage is in common use, in my opinion. That is the canonical representation that you get from Cloudera to do Hadoop on. Nothing wrong with doing virtualization on top of that. Absolutely not. Hadoop distribution vendors don't support virtualized implementations. Well, this is rapidly disappearing as a problem. It's a misperception. Hadoop is jointly tested and supported on vSphere with Cloudera, both direct attached and Isilon. And I'm going to show you the documentation on the Cloudera website that talks about this. If you like, there's a special relationship here between Cloudera and VMware. We're operating together very closely in this area. So people who are brand new to Hadoop here, completely new to it, listen to me now closely for the next minute. This is Hadoop 101. So what is Hadoop? It's a distributed computing platform. It has many pieces, worker nodes, that operate independently. The job that you submit on the top left-hand corner from your client or your gateway is broken up into pieces by this central scheduler, and the piece is allocated out to each worker, and each worker operates independently of every other worker. That's particularly the case when you have direct attached storage and you're reading data from that direct attached storage using a process called data node, which reads the data, feeds it into a container, and the container processes one block of data at a time. That's Hadoop in a nutshell for you. So what you've learned from that is that there is a file system made up of data nodes, and there's a compute platform or processing platform made up of a central scheduler and distributed managers, each controlling its own node. So these two go together. Resource manager is the central scheduler. Individual node managers manage the processes on their own nodes. They only have their own node. And in this world, in the physical world, a node is a physical machine. In vSphere, a node is a virtual machine, exactly translated one-to-one. So those two, resource manager, central scheduling, and individual scheduling on a particular node, they cooperate closely together. Name node and data nodes cooperate very closely together, and data nodes manage the set of blocks that are on their local system, and they pass those data blocks up to be processed. The name node knows about every single file in the Hadoop distributed file system. So the Hadoop distributed file system looks just like a Linux file system, except it's spread across many servers. It's distributed, and it's called HDFS, Hadoop Distributed File System. Hadoop Distributed File System is supported by these processes on local machines and one central process which must be alive all the time so that HDFS is available all the time. So now you've learned that Hadoop breaks down into two main segments: the Hadoop file system, HDFS, and the processing framework, which is made up of the scheduling and the local scheduling per machine. And these two together are called YARN, yet another resource negotiator. This is version 2 of Hadoop. Version 1 was very heavily tied to MapReduce. MapReduce is just a style of doing programming. MapReduce was taken out of the core of Hadoop, and it was generalized to running many different workloads across the system. That's called YARN, yet another resource negotiator. So that's Hadoop 101 in a nutshell for you. Each of these things, resource manager, name node, node manager, and data node, are each Java processes. And each of these containers is also a Java process. So there's a lot of Java in here. What's the first rule of Java on vSphere or anywhere else for that matter? Never overcommit memory when you're running Java in virtual machines on vSphere. Always keep your memory under control. So that old best practice that we've had for years still applies to this world. So that's Hadoop 101. Now what happens when I virtualize this? These are physical machines today. This is on a unique physical machine, and this is on a unique physical machine. And when Dwight is going to speak, he's going to tell you, make sure there's anti-affinity between those two processes, between the master processes. That's important so that no one physical server is the central point of failure in the system. When I virtualize, I do something very simple. I put each thing in a red box. These are virtual machines now. These 3 virtual machines may or may not be operating on the same host server. So the process of doing that, I'm going to show you, is using the Cloudera Director tool to talk to vCenter to say, clone me a new VM and place this software into it. That's all there's to it. And to place that virtual machine onto a server somewhere. That's the process of virtualizing. Dwight, I don't know whether you wanted to give this section.
There you go. Technical difficulties.
I'll do the slides for you.
Thanks. Yeah. All right. Hello, I'm Dwight Lahiri. I'm a solution architect at Cloudera. So thanks, Justin, for the slideware and the discussion so far. So how many of you know about Cloudera? How many know what Cloudera is? How many here use Cloudera? All right, quite a few. So for those who don't know, we are a big data company. We distribute Hadoop, which is an Apache open source product. We have many innovations and proprietary tools that we add on top of the Hadoop stack. So our objective is to make deployment of Hadoop fast, easy, and secure. And using a combination of all the products that we have in the Hadoop stack, we achieve that. So like Justin mentioned, the core of Hadoop is HDFS, which is the storage, distributed storage platform. And on top of that, it runs Yarn, which is a resource management, resource negotiation tool. And you can run multiple applications inside of Yarn. MapReduce being one that Justin mentioned. You can run Spark. And then we have, real-time, near real-time SQL engine called Impala, which you can use to do, SQL queries and use it for reporting in near real time. We have Cloudera Search, which lets you index and basically query unstructured data almost in near real time. There are many methods you can use to ingest data into HDFS from disparate systems. So structured data from databases using a tool called Scoop. You can ingest unstructured data, log data, and things like that from using tools like Flume and Kafka. So that is essentially, at a high level, what the Cloudera Hadoop stack is. We have Cloudera Manager and Cloudera Director, which basically let us operationalize and facilitate rapid deployment of Cloudera clusters. And then we have almost out-of-the-box encryption, end-to-end encryption and security features, which are not available with a lot of the other main Hadoop distributions. Next slide, please. So Justin mentioned some reference architectures. So we have two with VMware. One is reference architecture of VMware using direct attached storage, like Justin mentioned. Basically, just like you would do in a bare metal cluster, you have 2 use servers. Typically in a bare metal cluster, you would have 2 use servers with 12 to 24 disks in each server. And you build a Hadoop cluster, and each drive is presented as a file system to HDFS, and data is written across multiple nodes. With VMware, we can do pretty much the same thing. You basically create a mapping of one-to-one of your, okay, perfect. So here you can see that you have 2 VMs on a single ESXi host. And you have physical spindles, which you create data stores off of, and then assign 1 VMDK for each spindle, so that you get a one-to-one mapping of physical spindles to virtual disks. And that is very important in terms of performance, and we'll go into that a little later. And then you run the Hadoop processes in each virtual machine, and you can build a cluster out this way. Next slide. Or did you want to talk a little bit about...
Just one small point to add, and we're going into conversational mode here. I hope you find this good, which is that you'll notice that the virtual machine on the top left-hand side has exactly the processes that were in the architecture for a worker machine earlier. Node manager, managing resources on that virtual machine, and data node managing blocks. They both need to write to disk, but they're writing to disks that are exclusive to that VM. No disks are being shared within that one virtualization server. No disks are being shared across the VMs. That prevents I/O contention between them, because data bandwidth, I/O bandwidth, megabytes per second, is really important to get the best out of Hadoop, both on physical and on virtual.
Yeah, absolutely. So a few things. So I think we are going to show you where you can get the reference architectures from our website, Cloudera's website. But a few things to know about this, right? So make sure that you don't multi-home your virtual machines. Cloudera does not support multi-homed machines. And there are many reasons for that, security being one of them. Is when you use Kerberos to secure your cluster, and you have multiple IP addresses on the cluster, potentially on multiple VLANs, you will have issues, intermittent issues, which can be avoided by just using a single flat network topology. With virtual machines, one of the advantages of running a virtual infrastructure is to be able to move machines dynamically as needed, move storage dynamically as needed. But with Hadoop is a distributed platform already. So you don't really need to move machines. You don't really need to do vMotion. You don't need to do storage vMotion. For one, in this particular architecture, you have local storage and you're assigning the local storage to your virtual machines. So moving your storage becomes moot because all your data is already there on the virtual machine. And your data is not going to move when you move your machine. And then there is redundancy built into our architecture, right? So if you have, say, 20 virtual machines and you have, say, 15 worker nodes, so the 15 worker nodes are going to contain within themselves 3 copies of your HDFS blocks. So there's HDFS replicates data. By default, you'll have 3 copies of every block, HDFS block that's being written in your cluster. So there is no need to migrate your storage and things like that. I'm finding it hard to read that. Okay. So disable virtual vMotion, disable storage vMotion. For production workloads, ensure that your worker VMs are sized accordingly, so appropriately, so you don't have resource contention. And Justin mentioned something to that with respect to JVMs and not overcommitting memory. So the same rules apply. So those of you who work with Hadoop know Hadoop is a hungry beast. Hadoop will generate lots of I/O, lots of network traffic, and it's CPU intensive, memory intensive. So we talked a little bit about storage, storage area networks and storage arrays. You could, in theory, with 10 to 15 nodes, crash a storage array. Because in Hadoop, what we care about is throughput. So if we take a single machine, a worker node with, say, 12 drives, SATA drives, you don't really need to go very fancy with the drives. SATA drives are fine. And that's the most popular, SKU that's used for Hadoop clusters. You can generate up to between, say, 80 to 120 megabytes per second of throughput per drive. And Hadoop can drive each drive at that speed. So on a 12 machine box, you can generate 1.2 gigabytes per second of I/O throughput. So the point is that, when you design your cluster, you want to make sure that the storage subsystem, the amount of I/O it's capable of generating, can actually send that same amount of I/O over your network. So it's all about queues, right? So you have your storage subsystem, generating a lot of I/O. And make sure that your network pipes are large enough to actually hold the I/O. Otherwise, you're going to bottleneck on the network. So sizing your VMs is very important. Sizing your virtual switch and your physical network topology is also very important. And all the rules that you would apply for bare metal, cluster deployments are still applicable in this case. One rule is that's very useful is that you have at least one CPU core for every spindle that you have in your virtual machine. Like I mentioned, Hadoop can drive one disk at 100 to 120 megabytes per second. And by making sure that you have at least one CPU core for each drive, you can ensure that you're able to drive the ideal throughput on your virtual machine, your worker nodes. So again, Justin had mentioned about anti-affinity, and so what is anti-affinity? It's basically making sure that you don't have the VM starting up on the same physical host. So Hadoop, in a Hadoop cluster, you have 2 essential components. One is the worker nodes, and the other are the master nodes. So for high availability in Cloudera, we recommend having 3 master nodes so that they can take on the name node and the resource manager and yarn, the roles, and the failover component of it, right? So there'll be a standby which is going to always be around. When you have an issue with one of the boxes, it's going to fail over to the other one. So you want to make sure your master nodes never start up on the same physical host. So have strong anti-affinity on the master nodes when you're provisioning it in VMware. Okay, and so one more thing that actually VMware developed, which was a very cool thing, is Hadoop virtualization extensions. And that basically solves a problem where if you have two worker nodes sitting on the same physical box, you don't want a second copy of your HDFS block or a replica of your HDFS block going on that same physical box. So by enabling Hadoop virtualization extensions, what you do in essence is introduce a logical entity called a node group, which would map to your hypervisor. And doing that, you can ensure that you don't have duplicate replicas of HDFS, any HDFS block on the same physical box. If you lose that one box, you basically lose your data in that case if you don't use HVE in this case. So it's very important to use HVE. Did you want to add something here?
And that's simply a switch that you turn on when you create your cluster. So VMware added that code into the Apache code. Cloudera inherited that code from Apache. That's fully through the Apache process now. And that's something you turn on as a best practice when you create your cluster on Hadoop.
Right. And so in the reference architecture document, we have step-by-step instructions on how to actually implement HVE.
Written by Dwy, by the way. Okay,
Next slide. So sizing considerations, I think we talked a little bit about this, 100 megabytes per second per spindle is kind of the norm. You want to get at least 100 megabytes per second of throughput per spindle when you're using SATA drives. And just make sure that you have a 1-to-1 ratio for your CPU cores to the spindles. You do not oversubscribe your storage. So have, for every physical spindle in your cluster, have one VMDK. Don't have multiple VMDK sitting on a single physical drive. So even if you have like an 8 terabyte drive, don't carve it up into 8 1 terabyte drives and give it to 8 virtual machines. That's bad. That's going to be really bad for performance. Yeah, and network. So network is a big aspect here, right? So make sure that your network is not oversubscribed. You get full line rate on your machines, on physical machines and virtual machines as well. So that way, like I talked about the queues, you have the IO queue, storage queue, and you have the network queue. You're not bottlenecked on the network queue because Hadoop will generate a tremendous amount of IO. So if you give 12 drives to a machine, like I said, you can do 1.2 gigabytes per second of throughput. So with a 10 gig pipe, you can do 1.2 gigabytes per second, theoretically, of network throughput. So ensure that your network is designed appropriately as well. Do you want to add something to that?
No, I'm fine.
Okay, then we can move on to the next slide.
Let me do the Isilon part.
Oh, yeah, sure, yeah.
So in concert with the DAS approach, there's also this Isilon style, which is written up, again, by Dwy in a reference architecture, reviewed by ourselves at VMware. We regard this as a joint document. This contains all of the best practices that you would apply if you were doing an Isilon-based deployment. So these are two different reference architectures. You probably wouldn't mix the two. You choose one or the other. So if you're a beginner here, wondering how do I implement Hadoop on vSphere, you do have choices. You have choices to use here. And this is the type of, this is the type of architecture we'd select here. Now, the difference between this and the last architecture is these VMs only contain node managers and containers. They have no data nodes. They have no name nodes in them at all. So data nodes and name nodes are components of what part of Hadoop? HDFS. Good job. Good job. Data nodes and name nodes manage the HDFS. And where are they here? They're down on the Isilon server. They're not virtual machines. They're implemented by Isilon itself in its own software stack. It has an operating system of its own. And then these virtual machines are communicating over the network to get the data back and forth from these servers. So you can think of this as more of a centralized, more of a shared environment than the DAS approach in the previous architecture. And here, we're just running the compute side. Node managers execute containers, which execute the compute, the MapReduce, or the Spark side of Hadoop. So this is a different architecture, and you're going to say to me, isn't the network going to become the bottleneck? And potentially it is, but we've discovered in years of working with this that remote data is not completely out of the question. we started in Hadoop with local data, but having remote data is also possible. And this is data that is remote from the virtual machines. And we have customers doing this today. Best practices now from Dwight.
I just wanted to add one more detail about Isilon. So the Isilon backend itself uses InfiniBand, which is 40 gigabits per second. They have pair, and the fabric they build is over InfiniBand.
Down here.
And then the host that connects to Isilon is over a pair of 10 gigabit Ethernet bonded network interfaces. So the odds of you saturating at the network layer would be very rare, unless you've got the network not set up correctly. So it's very important, again, to make sure that your network is set up correctly. That's all. So with this, again, I mean, the same rules apply. Anti-affinity for the masters. Make sure that the masters have anti-affinity when you're setting up the VMs. You don't want multiple masters going down because the hypervisor went down. The same rules apply. Disable automated movement of storage and VMs. In this case, it's a kind of it's a disaggregated architecture where your storage component is actually in the Isilon layer, and you only have the compute or the yarn side or maybe just the Impala daemons running on your compute nodes, which are in the VMs. So in terms of where you present where you have the storage for the VMs themselves, there are multiple locations where you can do it. So your OS obviously can boot off of SAN storage arrays, which is perfectly okay. It's very important, again, to remember that when you provision storage for HDFS, you give about 20% of that storage for something called intermediate storage, where when, if a process, application like MapReduce is running, there's going to be shuffle that happens, and that gets written onto local drives, and not necessarily not on the HDFS side of things. So you always provision about 20% extra when you're provisioning storage. And that 20% can be spread across, it needs to be evenly spread across all your compute nodes or the node managers, as the previous diagram indicated. And these, again, the intermediate storage can be on a storage array. Make sure that the storage array is not, when you present those LUNs, they don't have very poor performance characteristic. So as long as they're decently performant, you can run it on that. A lot of our customers run these compute nodes with local SATA or SAS drives, so 8, 10 SAS drives per compute node. And then you can also use local SSDs. You can have 2 SSDs, and which can pretty much give you a very decent intermediate storage performance. So the point I was making earlier about how you distribute that shuffle storage, make sure it's evenly distributed across all your compute nodes. If you have 500 gig drives for a 100 terabyte data set, you would have about 20 terabytes required for intermediate storage. And you can break that up into 500 gig drives. So make sure if you have 8 VMs, make sure you have 5 drives given to each VM. That way, it's evenly distributed, and you get uniform performance characteristic across the board. Anything you wanted to add?
No, that's it.
All right. Again, same. I'm kind of repeating myself. But networking is very important. Make sure there's no multi-homing. We don't support multi-homing for various reasons, technical reasons. Network design is very important. When you lay out your network, think about using what's called a full mesh topology or a spine leaf topology. If you're using the traditional network model where you have, basically top-of-rack switches, aggregation switches, and core switches, make sure that when your top-of-rack switches go to the AG switches, there is sufficient, the ISL bandwidth is big enough for it to not be oversubscribed. So typically, we say that a 4-to-1 oversubscription ratio is about the limit. You should not go above 4-to-1. That is pretty much it in this next slide.
Okay, I think We'll skip this one. Okay, so let's now talk about new performance numbers that have come out this week, in fact. And these are the very modern workloads running on top of this type of architecture that we showed you, DAS, and running on top of Spark, which is the very latest innovation in Hadoop, and machine learning, as you're going to see. So we used a Spark workload here called Machine Learning Library. A machine learning algorithm takes samples of credit card transactions, a huge sample, maybe 1 billion samples, with 20 to 40 features in each sample, and says, I've trained my model to do this, to recognize patterns in this. Now give it Justin's credit card. Is Justin's credit card being used fraudulently because it's being used by somebody in Hawaii and Justin's not in Hawaii at this time? That type of detection, spam detection, identity detection, that sort of stuff. And these were driven by this workbench called Spark Bench, and there are 2 different types of algorithm here. I won't go into these algorithms, but you can read more about them. The big news is that Spark and machine learning with large quantities of examples and large quantities of data, 1 terabyte, 1.5 terabytes, and larger, virtualization in red comes in quicker by a factor of between 5 and 10% quicker than a native system. And you can read about this. There's a full technical white paper describing this. Lower is better on this graph. Lower bars are better. And these are completion time for the job, basically, in terms of 20, 30 minutes to complete. So this is the Spark Support Vector workload, which is a classic machine learning workload, about 5 to 10% better on virtual than physical. On the second workload, the opposite was true. Physical in green is about 3% better than virtual. And the reason for that is because Spark, as a general algorithm, is better when you give it more memory. And we carved these physical machines up into 4 virtual machines. Those 4 virtual machines had to share the physical memory, whereas on the bare metal side, Spark could use the entire memory of the physical machine. So when I talked to the performance engineers who did this, I said, how about if we use 2 virtual machines rather than 4 and gave them more memory? And he said that would make it about equal as far as performance is concerned. So in these slides, the only message I want you to take away, you can read the details from our white paper, is that you're within a couple of % of native when you virtualize. You're not losing performance, even with the very latest Spark algorithms and the very latest machine algorithms. You're still getting good value for money in virtualizing. So this pretty much repeats what I said, which is that written to disk at larger data set sizes showed a slight advantage to bare metal. Part of the data set was cached to disk. Not all of it was in memory. So larger memory on bare metal made the Spark executors, which is the containers running Spark, go a little faster. So now the Cloudera and VMware partnership at a technical level a little bit. And I'll delve into technology here, which is strictly technical preview. It is not shipping product as of this time. There isn't a commitment to ship this as a product, but we're very interested in your feedback on this. And if you'd like to try it out, we can put you into the technical preview program. Try this out and see what you think. So Cloudera, first of all, has a solution brief on the Cloudera website that describes the certification. So if anybody were to ever say to you, you can't run Cloudera on VMware because it's not certified by Cloudera, here it says Cloudera Enterprise is certified on VMware vSphere. Refer them to this document if they ever say that to you. But on top of that, we're working together on performance testing, as you've seen. We're working together on reference architectures. Our executives have talked to each other. The CTO of Cloudera, Amar Awadallah, is on video talking to our CTO. But we also wanted to do something that integrated us well into the Cloudera toolkit. And what Cloudera said to us there was, why don't you integrate with Cloudera Director? And let me explain to you what Cloudera Director is. First of all, this is all technical preview. This is something you would try out in your labs. So Cloudera Director is a tool for deploying CDH, the Cloudera distribution, including Hadoop, to any public cloud but now also to vSphere. And it does that by virtue of having a plugin that is specific to these particular environments. I think Cloudera themselves wrote the plugins to Amazon, to Google, and to Microsoft.
That's correct.
And we at VMware now wrote a technical preview plugin, which you can get from us today, to plug into Cloudera Director that deploys to vSphere. So the same tool to deploy everywhere is the idea. And this allows spin up and close down of clusters. You can do this interactively, or you can do it at the command line. You could integrate this with VRA if you wanted to via the command line tool. And certain customers are interested in doing that. So in this world, you have what's called an environment, a deployment unit called an environment. An environment is made up of 0, 1 or more Cloudera managers, which are deploying 0, 1 or more CDHs. So you have no limitations as to how many of Cloudera managers you will have or how many CDHs you have. You're only bounded by the capacity of your machinery here. So these are two different deployments which have one Cloudera manager in this case and two Cloudera managers in the second case. And Cloudera Director is composed of a server and a client, and we operate with both. But in the server case, we provide from VMware a plugin via the service provider interface. Effectively, Cloudera Director is saying, allocate me 10 machines. And we're allocating it 10 virtual machines. And then Cloudera Director is installing Cloudera Manager into the first one, and then telling Cloudera Manager, please go ahead and deploy CDH for me. So the old Cloudera Manager that you know and love, how many people use Cloudera Manager on a regular basis? A lot of people. So Cloudera Manager is still in the picture. It can still manage these things, but it's being used here by another layer, Cloudera Director, to deploy a cluster and manage it. And that's what we call the Cloudera Director plugin for vSphere. You can get more details from that from me. I've written a blog on it, jmurray@vmware.com, and we can supply you with this to try it out if you'd like. The benefit of doing this is you're completely supported by Cloudera and by VMware as you do this. In the old world, we built tools of our own that may be in some doubt between the two companies. So the idea here is to provide you with a user interface that looks exactly the same as if you were using Director to deploy to any cloud environment. Think of vSphere as your internal cloud now, into which you're deploying. So the user interface simply asks you to give it the name of the vCenter you wish to talk to, the port number on which vCenter is listening, the credentials to log into that vCenter, and a template. And once you've given it those 5 things, it's often ready to create a Hadoop cluster. And this Director user interface has a menu of choices of different shapes and sizes of CDH cluster that you wish to create. So if you were to participate in this technical preview, which you can think of as VMware and Cloudera looking after you together here, and we confer internally about it, you would get from us, with the appropriate agreements, a technical preview kit that has the Cloudera Director plugin, the node that's going to be cloned many times to create the cluster, and the quick start guide that's going to tell you how to get set up. And, you know, DNS forward and reverse lookup is required to be set up in advance. DHCP, if you use that, is required to be set up in advance. The basics that you need in every Cloudera cluster are needed in advance. But with that, you can spin up, scale down, and delete CDH clusters, and you can administer them, and you can use direct or shared storage, and you can implement Cloudera's best practices. That's our goal with this in the future. So we're really investigating your interest, customer interest in this, and figuring out if there is enough interest, should we take this forward? And we'd like your feedback on that. And there is a survey at the end that will ask you for that feedback. I won't delve into the user interface to this. This is all very early stuff. This is the creation of an environment, adding in the vCenter user interface details, and then finally, 3 or 4 steps later, we're creating our cluster by designing how many workers, how many masters, and how many gateways. These are the clients that provide interfaces to Hadoop, and I can use different templates over time to do that. So these are all prospective user interfaces, possibly not the real user interface when this comes out. And you can do this in batch mode without any user interface if you want to, from an automation tool, if you want to do it that way. That way you could use your own portal to say there are these 3 types of cluster, small, medium, and large, and call Cloudera Director plugin behind the scenes to deploy them. And there's no interaction at all with a user interface like this. Once your cluster is up, you can add a new Cloudera manager, add a new cluster, or scale up and scale down your existing clusters if you want to. So if you were very interested in this, talk to me afterwards, but you would sign a pre-release binary agreement with us. We'd give you the download site to download it from. You would set it up and run it. It's importing 2 OVA files, basically. You'd import 2 OVAs into vCenter, configure a little bit, and you're off and running. You should be up and running with this within a half of a day, if all the prerequisites are there. And then you can get support from both companies. First-line support from VMware, second-line support from Cloudera. I've actually used this myself. I've been the front-line support, and I've worked with Tony Wu at Cloudera, who's the second-line support on all this, and we support customers between us on this. So what we're looking for is this the right way to go for us? And we'd like your feedback on that. So Cloudera and VMware are working closely together, both at the product management and the engineers are working together. Our engineers from Beijing came specially to meet with Cloudera about a month ago. CDH is supported and a great performing platform on vSphere. We like the Cloudera product very much. We have this technical preview program going on, and our goal is to manage and deploy CDH clusters on vSphere just using Cloudera's tools, just as we would to any other cloud environment. That's the idea. So some benefits that we think: agility, resource utilization, leverage vSphere, and reuse existing vSphere expertise. These are things that come to you when you virtualize Cloudera CDH. I had the privilege of participating with some other authors in writing a book on this. If you're at the Hadoop 101 level and you'd like to learn the basics of Hadoop, this is not a bad introduction. There are plenty of books around about learning Spark and others that you can get hold of. And there are 2 more sessions that I want to recommend strongly to you. Tomorrow morning at 10 o'clock, you'll hear me warming up the people for a performance talk, a deep dive into performance. And you can get that, I think, in one of the rooms here. On tomorrow afternoon at 2:30, there'll be a talk about hyper-converged architecture. Sorry about the misspelling. Hadoop and vSAN as potential combinations. And then there's a Meet the Experts tomorrow afternoon from 3 to 4. I'll be helping with that. And if you want to read more, vmware.com/big-data is the place to go. vmware.com/big-data. So we'd very much like you to take this survey. If you take a photo or write down the goo.gl URL here, and maybe later on when you've got a free moment, take our survey. It's 4 or 5 questions. We'd just like to learn from you as to where we should take all this. I'll come back to this in a second. Thank you very much. This is our website, and there are some slides at the back end to do with other applications. I'll hang on this survey here in case people want to take a picture of it. Thank you, Dwight.
Oh, thanks. Thanks, Jeff.
Questions? Please come to the microphone if you have questions.
Yeah, thank you for your work on this. I think this is really useful. You mentioned shared storage. So is the VMware HCL coverage of shared storage vendors going to be something that will be auto-certified with Cloudera? Because there's been a lot of discussion about Cloudera certification and inability to get that. So shared storage vendors support with VMware, will they get grandfathered into the Cloudera certification that VMware is getting?
Okay. So I guess summarizing the question is, will there be a reference architecture that includes shared storage for Cloudera on vSphere? That sort of theme of your question.
It's more than that. I think Cloudera certification has been a prerequisite to deploy on shared storage. So now that VMware is supporting this architecture and shared storage is one of the options, is Cloudera certification still required for shared storage vendors?
Yes. So we do not support, well, I mean, for shared storage, if you're implementing shared storage and for HDFS, then yes, we do it on a case-by-case basis. We look at it. And because there are lots of, pitfalls when you're using, shared storage arrays, specifically around the performance characteristics. Like I mentioned before, I mean, Hadoop is extremely I/O hungry. So if you take a standard storage array, which is, enterprise storage arrays are not necessarily built to support massive throughput. They are there to support IOPS, and typically the workload profile is random I/O, whereas Hadoop is extremely sequential and very high throughput. So, like I said, a one box, 2U server with 12 drives can generate 1.2 gigabytes of per second of I/O. Your storage arrays, we would have to evaluate how you're implementing your storage arrays, what else is running on your storage arrays in order to be able to support Hadoop running on it in production. For non-production workloads, you are most welcome to run, set up your cluster on VMs, running on entirely on storage arrays, and as long as the caveat is that you don't expect it to perform at,
Did you have a particular form of storage in mind? Was there a particular model and type that you have in mind?
I was just going to offer up that, sequential throughput is not exclusive to Hadoop. There are data warehouses that require sequential throughput. Right. And even traditional databases within memory are now driving up sequential throughput. And some of the other vendors consider best practices like specifying what is the throughput and then how many nodes can you fan in. So how many compute storage node, what's the fan in. So is Cloudera looking at a more scalable model where you can publish similar requirements and we can meet the requirement based on the throughput that the vendor supports, so that we can work with VMware and then get this support in there through their certification? Because if VMware is working with Cloudera for certification, and now the vendor has to work with you again, that sort of defeats the good work that VMware has done here.
Right. And so that depends on customer demand, basically. So if we see a lot of demand, then, our product managers are going to look at it.
For sure. Yeah. For sure, yeah. We look at it on a case-by-case basis and figure that out. Yeah. We should talk offline about this. Other questions? Fire away. You've got Cloudera and VMware together on one stage here.
So I think there's a lot of good experience that VMware has over the years working with, with storage vendors. And one of the lessons learned over the years has been offloading storage operations like snapshots and clones through VAAI and vVol and other APIs has proved mutually helpful. It has helped free up CPU cycles so that VMware can host more VMs, and it's taken advantage of storage features that the vendors do best. Any thoughts? I know you talked about not using DRS and not using a lot of the features there because Hadoop has those features. But are you looking at the kinds of lessons learned that VMware has and leveraging offload now that we are working as a part of the VMware ecosystem here? And
I think, yeah, I think this is another storage question. I think our energy principally at VMware at the moment is going into vSAN for Hadoop. So rather than look at other forms of storage with VAI capabilities and DRS capabilities, we've had an exercise that you'll hear about tomorrow at the 2:30 talk, the STO talk that I'll bring up again. You'll hear there about performance measurements we've made on vSAN as a storage mechanism. So that's been our focus from a Hadoop perspective, because when we go and speak to our customers like yourselves, we say, when talking to Cloudera, you'll hear about direct attached storage. You'll hear about SSDs. Our customers react with, could we possibly use vSAN on top of that? And that's the most common request we get. We don't get a lot of requests for VAI and that type of technology underneath Hadoop today. So in general, when a question comes in like that, I typically say to our customers, measure the effective throughput to that shared storage device using iometer, compare it with the required bandwidth that you would need for your Hadoop environment, and if the two match, then you're fine. If there's enough bandwidth in terms of hundreds or gigabytes of megabytes per second, hundreds of megabytes or gigabytes per second, then you're safe. And measure it using a sequential long read and sequential long write algorithm, like you could do in iometer. So that's my classic answer to a shared storage question. But the type of shared storage that we've paid a lot of attention to so far is Isilon shared storage. The type that we're testing now with a view to running Hadoop on it is vSAN.
So if I can add just a little bit around that, right? So with Hadoop, your storage, if your storage backend is distributed, it scales better. If you have monolithic storage arrays, it doesn't scale. And about features like snapshotting, so you can do HDFS snapshots right now, and you don't need to do anything special to do that. So,
anything else?
The storage that you were running on vSAN, was it like a hybrid system or all flash or NAND or anything?
Great question. Was the test system that we were using with vSAN all flash or hybrid in the terms of SSD with disk spindles? The particular test that we're most interested in was all flash vSAN. And you'll see the results of that tomorrow at 2:30. Intel and VMware did that together very recently. There's some very encouraging results from that.
Thank you.
You're welcome. And actually, if I were being asked the more direct question, how would you do vSAN for Hadoop, I would immediately say all flash. Yeah. Thank you for that question. Other questions? We've come to the end of our Spark MapReduce Hadoop. Hopefully this was a good introduction for you. Thank you very much, and give us your feedback.